Science Museum has over 220,000 objects in its collection, and over 90% of them are kept in storage, many in these giant hangars in an old World War II airfield. But these damp sheds could quickly turn treasure into trash. The solution? Build a building within a building to stop the rot. And amazingly, they're making it out of cannabis plants. So, how do they do it? From aircraft to classic cars and even penny farthing, the storage facility houses over 16,000 amazing artifacts. But the Science Museum's Matt Moore has a problem.
The environment inside these hangars is quite cold and can be a bit damp. It's not ideal for some of our more sensitive items like the carriages.
What they need is the ultimate humidity controller. And as any scientist will tell you, nature usually has the answer. These fields are full of industrial hemp, a variety of the cannabis plant. But this legal crop has almost no drug content. It's being harvested for its versatility as a building material. And it's this hardy plant that will make up most of the museum's new building. Almost 50,000 acres of hemp are grown in Europe every year, and a single acre can produce up to 5 tons of the crop. Once harvested, the dry hemp straw comes here, Hemp Technology's state-of-the-art hemp processing facility in the east of England. The crop is made up of 2 main parts, the fiber and the woody core, called shib, used for building. To extract the shib, they have to break the hemp down, as plant manager Steve Holton explains.
This factory is all about separating the 2 components of hemp, the fibre from the woody component in the centre of it.
This $8 million machine separates the hemp into its constituent parts. First, it passes along a conveyor, where bales are sliced using a giant guillotine. Then the hemp enters the hammer mill to be smashed into pieces.
This is the hammer mill, which is the heart of the process. There's a 3.5-ton rotor, and there are 350 hammers inside that smashes it into the fibre and into the woody core.
The mill can separate up to 100 tons in a single day. A grid allows the smaller shib to fall through, while the fiber is sucked up by a giant vacuum. The shib is compressed and sorted into piles, which are then automatically bagged and sealed. And there's no waste. Up to 25,000 products can be made from hemp. The dust is compressed to make logs for fuel. The fibers will be used to make textiles and paper. Bagged and sealed, the shib is stacked by an auto palletizer. This robot costs $40,000. It can stack up to 200 bags an hour. The pallets are now ready to be loaded by forklift onto trucks. Next stop, Lime Technology's factory just outside Didcot in the south of England. Here, the shib is turned into the Hempcrete panels needed for construction. First, they empty the 925 pounds of shib into a telehandler, which then transfers it into this giant mixer. On its own, the dried hemp won't hold together. So to bond it, they use 1,820 pounds of material that was common on ancient Roman building sites, lime. Lime has the added benefit that it makes the panels resistant to mold. The final ingredient is 180 gallons of water. Powered by a 140 horsepower tractor engine, the mixer churns the hemp, lime, and water together to create a sticky mulch called Hempcrete that will harden and form a solid wall. The mix is poured into pre-made wooden panels. Then a team of workers compress the hemp and smooth it down.
Insulation's all about trapping air, but we don't want any big boys in there. It's a little bit like making flapjacks, I guess.
But the panels are extremely wet. To harden them, they need to be dry, as Piers Ashley Carter explains.
Behind me here is a large agricultural fan, and that dries air at ambient temperature through this spaghetti of pipes that we see along here, and that air dries the water out of it, and within about 18 hours it completely dries the panels, to less than 10% moisture content.
Once dry, a protective membrane is laid across the panel. This will allow moisture to pass through, maintaining a constant humidity level inside the finished building. The panels are then loaded onto a truck to be taken to the museum's construction site. Each panel can weigh up to 900 pounds, so on site a forklift is used to carefully position each one. The precision panels have been designed to fit together like a giant jigsaw puzzle. As the forklift lowers them into place, a laser is used to align each one perfectly. Then they are tacked into place before being secured to the building's metal framework. The hemp will act like a natural air conditioner, keeping the environment cool. And despite being a strain of the cannabis plant, you can't smoke this. Hempcrete is fireproof. 16 weeks and 150 hemp panels later, the Science Museum's new storage facility is complete. The shelves will soon be stocked with some of the most important scientific relics of our time, including fragile notebooks belonging to Albert Einstein. Completing the project, pipes draw in cool night air to maintain a constant temperature. The museum's Matt Moore is delighted with the results.
All the tests and all the indications are really positive. They show that it's going to stabilise the temperature to the right levels for us to manage our collections properly.
Safe from condensation and humidity, preserved for future generations to enjoy, and all thanks to a humble weed.